Hello all, welcome to Ambari Cloud Data video. I'm going to present metrics. When you do RAG application or any LLM applications, you need to evaluate how your application is working. Diagnosing and fixing a broken RAG pipeline. And so here I'm going to use one prompt, 4 metrics, and I'm going to a complete fix walkthrough. In this video, I'm going to discuss what are the 4 metrics, right? Context relevance, groundness, answer relevance, and correctness. Okay, let's walk through. So what is the prompt we're going to use? We're going to use what is pizza toppings do you have? And you might already have a RAG vector store, and you store all the documentations and everything for pizza toppings and all that stuff. So generally how the application works, we're going to retrieve. So for that we have a retriever, search knowledge base. And then you're going to send your documents from your knowledge base along with your prompt. So basically you send the prompt, query, and context. Then LLM generates the response. Then you can print the final answer to the user. Then you're going to evaluate, you're going to grade it against your ground truth. What is the ground truth here? You have a known prompts, then expected answers, right? So you're going to have a set of data, and so you validate, and you want to make sure your application is working. So we have a grader correctness. Okay, so what are the metrics we're gonna look for? Okay, first is metric 1 is a context relevance. Did the retriever find the right documents? So in our vector store, are you able to when you submit your semantic search, we'll let that particular vector store and find the proper documents based on your prompt. So it depends on Euclidean distance or whatever model you are using, L1, L2s on your vector store. Okay, and then you're going to send that information to the LLM. So LLM generates the answer based on your documents, and then the documents, which is the context you send, and then based on your prompt query. Did the LLM stick to the context? Right? So that means you give the documents, but LLM generated based on your prompt. And does the response answer the question? Answer relevance. Ask for what pizza toppings do you have? And did I get the answer? And here we want to do a correctness. Basically, you have a predefined data saying that for a given prompt, I should get the answer. Then you need to. So basically here we are doing the ground truth. Does the response matches the ground truth? The final answer relevance matches the ground truth, not the groundness here. Groundness is LLM hallucination or LLM response. We ignore the hallucination for now. Look for the response. But here ground truth is fixed prompt, fixed answers. And then it matches your answer. Let's go to the metric by metric. Context relevance. Did the retriever find the right documents? What pizza toppings do you have? That is my query, user root query. Then in your vector store, based on your semantic search, and then how the documents you loaded, and you got this one document, weekly groceries list, eggs, milk, bread, butter, orange, and another document retrieved, staff rota for Friday evening, whatever. So what was needed? The pizza menu listing all available toppings. So it didn't retrieve the context. If you look at the context relevance is just 0.15. The retriever fetched a grocery list and staff rota, neither mentions toppings. The LLM has nothing useful to work with. So the score is 0.15 out of. So the framework identified this relevance is, has very limited. So what do we need to do that? Okay, so since we are talking about this, we had to fail context relevance, then we need to fix our document system. So re-embed the pizza menu or tune chunk size or adjust the record sets, config, and all kind of stuff. So basically you need to tune your embeddings, embedding, maybe you're going to choose a better embedding model, and also check the chunk size and search models and all that stuff. So you have to work on your vector store. Now let's look at the second metric, groundness. Did the LLM stick to what was in the context or making things up? So what is the context given here from the document sets? Groceries list, eggs, milk, bread. No pizza menu was retrieved. But in the prompt, we ask for what are the toppings. And LLM response is we have pepperoni, mozzarella, mushrooms, oil, and seasoned burrito. Our signature is the gold leaf mosquitoes. But it's not there in the context. But the LLM, did the hallucination. None of these toppings appear anywhere in the retrieval documents. Every claim was hallucinated. So LLM made it up. So every claim in the response was fabricated. The LLM has no pizza menu, so it is invented plausible sounding toppings. So our groundness is fair. So what we need to do is we need to adjust the prompt, tell the LLM, we have to instruct the LLM either through our prompt part of our prompt query or maybe system prompt. Only use information from the provided context. If the answer is not there, say you don't know, don't hallucinate, don't invent. Yeah, so you can add this one as part of your system prompt, telling that instructions to the LLM. Next, metric 3, answer relevance. Does the response actually answer the question what was asked for? Let's assume we gave better documents in our retrieval store, right? LLM is not done any hallucination, but it's still giving some weird data. What pizza topping do you have? Great question. Pizza has a rich history dating back 18th century in a place. Our restaurant was founded in 18. So it is giving something restaurant information. No, it didn't answer my question. So the answer relevance is low. No user asking for topping. Response covered history and ambience. Intent completely missed. So again, the metric is value is low. So here also we need to provide some system prompt and answer the user exact question directly. Do not add unrelated information. So you can put it in your system prompt or in your prompt, making sure, hey, do not hallucinate, do not invent, and give me the answer properly. So you need to tell LLM. So basically, you have to kind of a guardrails here. Correctness. Does the response match the known correct answer? Ground truth. And you have to do, so you build a list whenever you're testing an application, you build your, your own prompts and what is the answer for it. Let's say, for example, give me the top 10 users, who is ordering pizzas in this county or this city. And you may have answers for those. So if you identify those kind of prompts and then you have an answer, you have a corresponding SQL, keep that one as a ground truth, and then compare your answer with your ground truth. So you store your ground truth data in a table, and you can use that information to your framework. Then framework say, okay, I got the answer, I know the ground truth, I know the actual answer, then it will know the correctness. We have a, so again, ground truth is pepperoni, mushrooms, bell peppers, onion, olives, mozzarella, and fresh basil. This is the ground truth is stored in, what is the toppings. But the LLM response was totally different. So only one of the topping, pepperoni, was identified. For example, if they give the answer like this. Okay. So how do you reach this? Number 4. Yes, we have to work on, metric 1, 3. right? First identify the documentation from a retriever, and if retriever is good, then you might have to work on preventing the hallucination, then or maybe right intent and templates and then all the stuff. So we have to work on 1, 2, 3, how the data is coming in. Okay, so these are 4 metrics you need to test whenever you want to deploy your RAG application, your LLM applications before you getting into the production. And you need to have this one, and then you need to enable as the new data keep changing. You need to run this one again. Or what if you change the model, right? You may correct these known prompts for tester create. So basically, this is kind of your part of, not kind, actually it is part of your observability testing, right? You need to compare model 1 to model 2, right? So let's say you have model 1, ChatGPT 1, then after 1 year you may have ChatGPT 5, and you're testing it when ChatGPT 5 is more smarter than ChatGPT 1. So you need to have your baselines, basically here, the ground truth, and continuously test that, make sure your application meeting these ground truths. And then if not, then you need to come back and fix your prompts, fix your templates, okay, system message, or guardrails and all the stuff, and your retriever too. Okay, so context relevance, retriever, right, and retrieval, all these values are low. Groundness, LLM generated, LLM hallucinated, and final answer is bad. And then we compare the final answer with the ground truth, and then even basically evolve data set. So now once we have this, right, and what we need to do is, okay, all four failures share one root cause. The retriever never fetched the prism menu. So that is the root cause here. So sometimes if you have a best retriever, yeah, then 2 and 3 will automatically fix. So fix metric 1 retrieval and metric 2 and 3 all improve automatically. Always debug the pipeline from left to right. That is a rule. So sometimes even if your retriever are successful, then you may have additional hallucination, and LLM is trying to add more because it knows a lot of stuff. So you need to put some your system prompts and templates saying that, okay, stick with my retriever documents. Okay, so now let's see what we do is, and so did the retriever find the right documents? Yes. Okay, let's do that. Groceries list eggs, milk, bread, and then another document. So right now we fix the retriever. So it's identified wrong correct documents. So yes. So here, make sure that you change your, depends on which vector story you're using, right? Make sure that you get the correct relevant documents. Relevant documents is the keyword. Roundness, fix the hallucination. So did LLM stick to what was in the context? So here the context is pizza menu with all toppings, and then response was pepperoni because we fixed the retriever, right? And then look at here, we unified system prompt, grounding and direct answer, list formatting. So you can have it for your groundness, and then your the your third one is your answers. Stick to the answer, direct answer. So here you are a helpful restaurant assistant. Only answer using information. The context. Do not add or invent any information not in the context. If not in the context, say I don't have that information. Answer the user question directly. Lead with answer. If listing of options format is clear as a clear list, then you have to use context. Context equal to context, which is retrieved, and user question as a query. So basically, this is your system prompt. You can do that, or the different. There may prompt. You have to get into additional prompt engineering examples. Or you can also give some, examples in your prompt. You can also give data model in your prompt. You can give some SQL queries and corresponding answers in the prompt. Or also you can give your data formats and data types, foreign keys and primary keys, foreign key relations, primary keys and nulls, not nulls. And then, yeah, you can give more information. Of course, you don't want to create a massive system prompt and it eats the tokens. So look at this one. We just change the prompt. Of course, we change the retriever, make sure we get the correct context, the documents. Okay. Then, of course, answer relevance. We are using the same prompt. Now, I got the correct answer. Look at 0.96. Okay. And then, yes, it's matched. So here, if you look at the sentence transformer, it's your vector store. You submit your prompt, and then prompt is converted into chunks or tokens, and then did the search on it, and then you got the groundness values, and which is no hallucination. You got the correct answer. Then once you got the correct answer, now what you did is you compared with your answer with the ground truth, right? And then I got the answer almost 0.9. It's almost equal to 1. Right. So here, yeah, I all my data in a ground truth table, right? And then I should be able to compare with my actual answer with my ground truth answer for a given prompt. Then it's successful. Okay. So if you look at the before fix, after fix, right, and you can improve your quality of your AI application. But again, very important, just because you build an AI application, you already have a prompt, you have a vector store. What if your vector store data was not loaded properly? What is the chunks? The chunks are not done properly. What I mean is chunk size. And what if the between two chunks there is no relevance? And overlapping, you have to look at the overlapping. Is the overlapping is fixed? Or is it overlapping done by through agent? Or what if between two pages when you load the documents? So you have to look at and make sure that your document and change size, and then so maybe sometimes you might have to hierarchical chunking. Then prompt is very important, right? You have to phrase it properly. Then at the same time, you have to set your expectations from your LLM. Then what you want, what is the format you want, and you want in the JSON format, and then or maybe bullet point style, and then you want to give instructions to LLM, do this, don't do that, and all the stuff. So that's why you improve these metrics. So user query, yes, you have to fix it. Retrievals, make sure that you are getting correct documentation. You can get extra document, which is fine as long as you get the relevant documents. Maybe you might have to ranking if you get too many documents. Then after that, then you want answer relevance. Then finally, correctness. You have to run this correctness, making sure the numbers are matching or context or your information is matching. So this is how you build your AI observability or testing. So as soon as you build your application, add observability module, then enable it and test it in randomly some prompts, and then deploy it. And whenever you want, run this observability on your existing application production. Then keep collecting these metrics. And these metrics are stored in database, either in Snowflake, or you can run it on Postgres or any other, or you upload to other third-party tools, and then you can get all information. So make sure once you complete your testing or your build application, add the observability modules. TrueLens is the commonly used framework. Run this, all four metrics, and making sure you get a better metric values for. So more prompts, more ground truth is better always. So look for that. Okay. So if you look at re-embed teaser menu here, right? Embedding is a big thing, right? Look for what is embedding size, and then grounding instructions fall back to system prompt, and rewrite prompt templates, which again system prompt and intent. and then look for correctness, right? So this is how it's continuous process. Okay, remember, LLMs are probabilistic, not deterministic, but we are trying to get more deterministic. But more prompts you tested, and then with this 4 metric approach, you will have more success in your AI applications. Okay, so always start with the retrieval metric 1, which is more important because that's where most of the issues we will see. Is a single most impactful fix. Yes. Okay. Then of course, you fix your system prompt. If not, trying to give grounding instructions, anchor the intent. So what you are expecting. Okay. Check the correctness. So always left to right. Any questions? Reach out to me. So Body Cloud is